Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over our virtual algebra text on systems of equations, focusing on how to solve systems by graphing. Alright, before we take a look at an example, we're going to take a look at the possible types of solutions you can have when you're solving systems of equations by graphing. Okay, so let's take a look at the first type of solution we can have. On the first coordinate system, if you have two lines, let's say you have a line like this, two lines that intersect at a point, in that situation, you have exactly one solution. Okay, so in this setup that we have right here, we have two lines that intersect at one point right here. In a situation like this, when you have one intersection, you have exactly one solution. Okay, so this is one of the possible outcomes that you can have. So in this case, if this were -1 and this were 1, your solution will be -1, 1. Alright, another possible scenario that you can come across when you are solving systems by graphing is a situation where the two lines never intersect. Okay, so if you have two lines that never intersect, what kind of solution will you have? So two lines that never intersect are basically classified as parallel lines. So if you have a line like this and another line like that, in a scenario like this where the two lines do not intersect, you have no solution. Now, how do you know that two lines do not intersect? If they're parallel, how do you know for certainty that they're parallel if their slopes are the same? Okay, so in this case, we have no solutions. This one we had one solution because we had one intersection, right? The intersection is the solution. So if you do not have any intersections, then that means you have no solutions. All right, so no solutions basically because we have no intersections. And the reason why we have no intersections is because we have parallel lines. Parallel lines. How do we know that two lines are parallel? If their slopes are equal. Okay? If two lines have the same slope and if they have the same slopes, then they are parallel. If their intercepts are different, then you know that they never intersect. Okay? Now the final possible solution you can have is a situation like this where you have you graph the first line and then you graph the second line and they are the same line. Okay? If two lines lay on top of each other perfectly, the question is, how many solutions do you have? Well, the number of intersections tells you the number of solutions that you have. If two lines are exactly the same line, they have an infinite number of intersections. So that means you have infinitely many solutions. Infinitely many solutions. Why do you have infinitely many solutions? Because you have infinitely many intersections. Infinitely many intersections. Okay? So I hope you can visualize why we say we have infinitely many intersections. You have infinitely many intersections because at every point you have an intersection. Any point you select on the line, you have a point of intersection. How many points are there on a line? You have infinitely many points on a line. So that's why you have infinitely many intersections. Okay? How do you know that you have a scenario like this? Is when you have the same line. All you just have to do is put both of them in the same form and simplify them completely, and then you see that you can determine if they're the same line or not. Alright, let's take a look at an example. So in this presentation, we're going to solve the given system using the graphing method. Alright, so the problem we're going to be looking at in this presentation are lines that are presented in standard form. Okay, so let's say we have x plus 3y equals 9 and 5x plus 3y equals negative 3. Okay, so we have these two lines given in standard form, and we want to determine what the solution is by graphing. Okay, so what we're going to do is we're going to proceed to label the equation. So we have x plus 3y equals 9. Let's call this equation 1. And then 5x plus 3y equals negative 3. We'll call this equation 2. Alright, so to make the graphing process easy for us, what we're going to do is convert both equations from standard form into slope-intercept form. Okay, it's much easier to graph a line using slope-intercept form. You can definitely graph it here using standard form, but we're going to use the slope-intercept conversion approach. So let's start with the first line. So let's write what we want to do first. So what we want to do is we want to place or rewrite both equations in slope-intercept form. Slope-intercept form. What on earth is a slope-intercept form? The slope-intercept form is y equals mx plus b. So what we're basically trying to do is isolate y in both equations so that it's easy for us to graph. Okay, so let's start with the first line, line 1. I'm going to deal with this line in, let's make this blue. So line 1 is going to be in blue. We have x plus 3y equals 9. Now this is the standard form. Standard form. What is the standard form? The standard form is ax plus by equals c. Okay? We want to put it in the y equals mx plus b form. To accomplish that, we're going to subtract x from both sides and then divide by 3. Okay? Let's go ahead and do that. Subtract x from both sides of the equation. And that yields 3y equals negative x plus 9. And then divide both sides of the equation by 3 in order to isolate y. Alrighty, so if we carry out this division, we're going to have y, because these 3's divide out, 3 goes here 1, 3 goes there 1. And then we're going to write this fraction. Negative x over 3 can also be written as negative 1/3 x, just to make the coefficient more obvious, plus 9 divided by 3. 3 goes here 1, 3 goes into 9 3 times, plus 3. Alright, so we have the first line in slope-intercept form. If we want to graph it, we just need the slope and the y-intercept. So we're going to write y equals mx plus b. M is the coefficient of x, and b is the term that's been added, the constant term that's been added to the mx term. Alright, so just a side note, we have accomplished the rewriting process. This is the slope-intercept form. I hope you can see why it's that, because you have y by itself and then mx plus b. Okay, now to graph this line, we need the slope and the y-intercept. The slope is given by m. It's the coefficient of x. The coefficient of x is negative 1/3. So what does this mean in the context of graphing? Well, these are the movements, okay? Since the rise is negative, it's actually going to be a fall. You're going to fall 1 and you're going to run 3, okay? So these are your movements. Think about m for slope and m for movement. And then our y-intercept. Y-intercept is the b value, and it is this number right here. The b value is 3. Okay? And this basically means that we're going to begin from 3 on the y-axis. Okay? Begin from, if we graph the y-intercept, is going to be 0 for the x and 3 for the y. Okay, so for y-intercept, the other coordinate, namely x, is going to be 0. That is when the graph cuts the y-axis. Alrighty? Okay, so we have all the information we need. We can use this information to graph the first line. So while we're at it, we might just go ahead and graph the first line. And then we can graph the second line once we have sufficient information. Okay, so for the first line, we're going to start off by graphing the y-intercept. Remember, we said that is where you begin from. Okay, so I'm going to make this one, I'm going to make it blue. Alright, so your y-intercept is 3. So we have 1, 2, 3. So y-intercept of 3. And then we're going to rise 1, -1, which is a fall. So we fall 1. And then we run 1, 2, 3. Bam. So these are the 2 points that define the line. Alright, let's put in more points in our graph. So rise -1, which is a fall 1. Run 1, 2, 3. That's another point. And then we've run out of space here. So if we want to create the points to the left of this y-intercept, we'll do the opposite. Instead of fall and run, we're going to rise and back up. Okay, so 1, up, 1, 2, 3. That's another point. And then go up 1, back up 1, 2, 3. That's another point. Okay, we can stop there. So we're going to go ahead and draw the line. Ensure that your line intersects the entire grid. So something like that. Okay, so this is our first line. Let's label it. This is line 1. Okay, now what we're going to do next is we're going to proceed to graph the second line, namely, alright, let's go ahead and graph the second line. So the second line is presented in standard form also. So equation 2 is 5x plus 3y equals -3. So we're going to place this in slope-intercept form and then graph. Alright, the form that we're given, this is the standard form. The standard form is ax plus by equals c. Okay, now to get this in slope-intercept form, we're going to subtract 5x from both sides and divide by 3. Alright, so subtract 5x from both sides, and that will give us the -5x plus 5x, they add up to 0. We have 3y is equal to -5x plus 3, minus 3, sorry. And then to get y isolated, we're going to divide all 3 terms by the coefficient of y, which is 3. So divide by 3, 3, 3. And then 3 goes here, 1, 3 goes here, 1. And that gives us y equals -5/3 cannot be reduced, so we just write it as -5/3x. And then 3 goes here, 1, 3 goes here, 1, minus 1. Alright, so with this form right here, we can easily determine what the slope and y-intercepts are. So with this format, if we just put y equals mx plus b underneath, let's do that. Y equals mx plus b. You can see that m is -5/3, the coefficient of x, and b is -1. Alright, Alright, so let's go ahead and write that down. Our slope m is -5/3, which means we're going to fall 5 and run 3. Alright, these are movements. And then our y-intercept, where we're going to begin from on the y-axis, y-intercept is the b value, and in this case it's -1. Alright, so this is where we'll begin from. We're going to begin from the point 0, -1. If you graph the y-intercept, is going to be 0, -1. Alright, so let's go ahead and graph this line on the same coordinate system. So the y-intercept is -1. So right there, -1, 0, -1 is your y-intercept. We're going to rise -5, so go 1, 2, 3, 4, 5, and run 3. 1, 2, 3. Bam. These are the 2 points that define the line. Okay, let's graph some points to the left of the y-intercept. We're going to rise 1, 2, 3, 4, 5, and then we're going to back up 1, 2, bam, 3. Now this is special. We see that we have a point that's common between the two lines. That point is called the point of intersection. Okay, and that point is of great significance in the context of this problem. We're going to talk about what that point signifies in a second. Okay, so we draw our second line, and we see that both lines intersect perfectly at that point right there. Now that point represents the solution to the system of equations that we are trying to solve. Okay, so this point right here is the solution. So what's the solution? You look for the x-coordinate. The x-coordinate is 1, 2, 3, -3, and the y-coordinate 1, 2, 3, 4. So in conclusion, the solution, let me change it to black. The solution to this system of equations is basically the point of intersection. We have exactly one, which is -3, 4. Okay? So what does this mean? This basically means that when you plug this point, -3 for the x and 4 for the y, if you plug it into both equations, you are guaranteed to end up with a true statement. Alright? So that means that's what the significance of the solution to a system of equations is. Alright? So how well did you master the contents of this presentation? To demonstrate mastery, we would like you to try out the following problems. And then when you're working on the problems, you would like you to pause the video. When you're done solving the problems, you click on the playback button, and then you will see what the answers are. Okay? So the instructions are for you to solve each system of equations by graphing. Alright, so number 1, let's say you have the system x plus 3y equals 9 and x minus y equals 1. Number 2, what if you have the system 7x minus 3y equals 12 and 2x minus 3y equals -3. And lastly, what if you have the system 7x minus 4y equals -12 and 7x minus 4y equals 8. Alright, so go ahead and pause the video at this time and try out the problems. When you're done solving all of them, you can click on play to see what the answers are. Alright, hopefully you had a chance to try out the problems. These are the solutions. So the first one, it's 3, 2. For the second one, the solution is 3, 3. And then for the last one is no solution. If you graph it, you find out that they both have the same slope of 7/4, but their y-intercepts are different, so that's why they never intersect. These two lines are parallel with different y-intercepts, so they never intersect, hence there are no solutions. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of systems of equations, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments or special requests for tutorials, please send in the comment section below and we'll be more than glad to assist. Do not forget to subscribe to our channel for updates to other presentations such as this. More videos, worksheets, games, and tools can be found at our website at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.